Today, we're going to cover a medium decode question named decoded string at index. If you haven't seen this question before, I would strongly encourage you to try to solve this by yourself. It is because even though this is a medium question, it actually involves a lot of details and many corner cases you need to handle during the implementation. However, if you really get stuck somewhere in the middle, that's the reason why this video is here for you. Let's go over this together. In this question, you are given a string S, which is composed of only letters and digits. You need to follow the below procedure to expand the string. If you see a letter, you will directly append that letter to the final string. However, if you see a digit D, then you need to repeat the final string D times. At the end of the expansion, you are given an integer K, and need to return the K letter in the final string. There are a few constraints you need to pay attention to. First of all, there are at most 100 characters in the original string. The digit is ranging from 2 to 9, and the K can go all the way up to 10 to the 9th. Now let's take a look at the solutions. The very first solution I can think of, I will call it full expansion. What I want to do here is to follow exactly what the problem description asks me to do. We'll first do the expansion to the very end, and then find the kth element in the array. Just for simplicity, I'm going to make a test case myself. So let's say I have a single A, followed by a digit 3, B, 2, C, 2. And let's say I want to find the kth element. Because I want to do a full expansion, what I want to do is I'll actually expand it with 3 A's, and then append a B here, and then do it twice, append a C here, and do it again. After the full expansion, what's the kth element? That's very straightforward because it's here. I will just return a character instead, right? So this is K. This sounds very straightforward. But what's the complexity of this algorithm? In terms of the complexity, we need to think about the worst possible scenario. And the worst scenario is a single character followed by many digits. If I have a 9 following an A, what I will get is 9 A's, right? But what if I have 2 9's after an A? Then we'll have 9 to a square A's. And we keep doing this till the worst possible scenario, which is I have a total length of 100 characters and I have 99 9's here. In this scenario, I will have 9 to a 99 A's. In C++, usually we can finish 10 to the 8 to 10 to the 9th operations per second. In Python, we can probably do 10 to the 6, 10 to the 7. But here we're talking about 9 to the 99. It's a super large number. It will not be able to finish in seconds, actually even in years, in centuries. This is definitely not a feasible solution to this question. Let's move on and think about what else we can do. The second solution you can think of is called partial expansion. Instead of expanding the string to the very end and find the kth element, probably can just expand it while we are finding the answer till the point that we find the kth element and we stop there. What I want to do here is, for example, let's keep doing this. We start with 3 A's. Have we found the answer? No. So we'll add a B here. And then we'll expand it twice. Now, do we find the answer here? Yes, because we are going to find the kth element, which is 6th element in a string of length 8. Where do we find it? Do we need to expand C, whatever? We don't need to do this part. We define our answer. And this sounds like a very easy improvement to the algorithm. And let's think about the complexity of this. The complexity of it is actually bounded by K, because we'll only do the expansion up until K, and we stop here. This is the expected complexity. But is this good enough? Unfortunately, no. As we mentioned before, given that K is up to 10 to the 9, we still cannot finish the execution of it within a second. Let's explore if there's a better solution than this. The final solution I have in my mind is called lazy expansion. And as you can tell, I want to be lazy. I don't actually expand the string. We know that before the first digit, I only have a single character A. It's length of 1, and I need to repeat it 3 times. After that, I have another string called B. It's again length of 1, and then repeat it 2 times. Lastly, I have a character C. It's a length of 1. I need to repeat 2 times. All right, so I have 3 tuples here. On the first tuple, I know that I can make a string up to length of 3. It's a single character. I will repeat 3 times. It's a length of 3. If we including that with the second row, what we get is 3 plus 1. So we have a string of 4, and we need to repeat twice. We can have a string of length 8. Right? And we can keep doing this for the C, so it will be A plus 1 times 2. And then that gives us 18. How does this help us out? This time, we don't actually build a string itself, which is, we know, very time consuming. But this time, we're just playing with numbers. And we actually know where the kth element locates. It's definitely not in the final string because we define it after considering the second tuple. We should just dig deeper into this. Just for visualization, what we actually will have to build is, what we actually built before was this string. But this time, we don't want to build it. We want to search for it. In our imagination, we're to build a string of length 8. And we just need to know the 6th element of it. Before we duplicating the string by 2, what we have is actually AAAB and AAB. And given that the ones we need to find is 6, we know that it's not in the first part, but in the second part. Let's play slowly here. So it's because 6 is larger than 4. But how do I know which part it is in? It's actually in the 6 divided by 4, which is the 1 part. So this is the 0 part, this is the 1 part. And we also know its index of it, because if you do a module, we'll know it's actually located at the second character in the 1 segment, not the 0 segment. We actually know its location. Because of this, we know that this answer must fall into the first part, because we know that the first part is composed of AAAB, like 3 A's plus a B. Because we know that the second element, we can return A directly, right? So this is basically how this solution works at a high level. Instead of expanding the string to the end, we can actually just play with numbers. And we will first, from top to bottom, try to find out where the string is, and we'll go the way back and actually identify which character we need to return. If this still sounds a little bit complicated to you, that's totally fine. We will explore more in the actual coding part. So previously, we talked about 3 different solutions. And the first and second solutions are actually not feasible, or they are not fast enough to be used in practice. So here, we're going to only implement the third solution. So the third solution is what I call lazy expansion. There are multiple steps in the solution. The first one is called Decoded. And in order to demonstrate what I mean, I'm going to use the same example of A3, B2, C2. All right. In the build tuples step, what I need is to maintain a tuple picture, and also at the same time to have a list to maintain the standalone characters like between digits. Okay. I'm going to iterate through the string, and there are only 2 possibilities of the type of C. It's either a digit or it's not a digit. If it's not a digit, then pretty straightforward, I can just append that character into the pattern list. And however, if it's a digit, what I need to do is to make sure I build a new tuple of it. And the new tuple is composed of the pattern joined by an empty space plus the number of repetition itself, which is int of C. Remember that after we use the pattern, we need to clean up so that the new pattern to the new characters following it. At the end, before we end this part, it is possible that the pattern is actually non-empty. If it's non-empty, we actually need to make sure to append the remaining. We actually need to build a new tuples on the remaining pattern. The only difference here is that this time we only need to repeat the string once. That concludes the build tuples part. Now for the search part, there are 2 components. The first one is for us to identify the last tuple that needs to be involved. And the second part is actually do the kind of a backtracking to figure out which character we need to return. Let's start with the first one. First, I would like to name index called like tuple index. I also want to maintain the total pattern length starting from 0. This tuple index will start from 0 all the way to number of tuples. And I would like to know what exactly I have in each tuples. Now, every time I got a new pattern digit, what would that happen to my total pattern length? So my total pattern length should be always plus equals to the length of the pattern times digit. For example, if we use, when I have AA, I will append a B here and times it twice. Right? If the total pattern length is larger or equals to K, then we'll basically do a break here. Otherwise, I will increase the tuple index by 1. I also want to quickly point out here that I don't really like having index at 1 index. The easy fix there is to minus equals to 1 for K, and then this is converting 0 index from 1 index to 0 index. And because of that, this also needs to be changed. That should be it. So far, we defined out the last tuple we are interested in. And now the next part is to find out which character we should return. In order to find out the character we need to return, we need to do the back search again. This time, the tuple index will from where it was all the way to 0. And again, we need to find out the pattern and digit of it. Now I'm at 8 characters here. I want to know if K equals to, because of now we change to 0 index, K equals to 5. I want to return the second A here, right? However, if the K equals to 7, then do to return B. How do I know that which one I want to return? The way I do it is I will first revert the last action on the pattern, total pattern length. So I will first divide it by digits. And after that, we will see now the total pattern length should be 4. And by just doing a modular, I will know which index I'm interested in. I'll do a K mode by the total pattern length. After the modular, there will be 2 possibilities. One is, it actually happened in the new pattern, like the pattern we care about here, or it's before it, right? It's like it could be from like previous patterns after the digit repetition, whatever. It could be before it or right at this pattern. And actually, it's easy to check it. I will first do minus equals to length pattern. Now, the K might be either larger or equals to the total pattern length. It means now this K falls into this pattern. In that case, I will just return pattern K minus total pattern length. If that's not the case, then basically I need to keep doing this and just go the way back. I will do tuple index minus equals to 1. And if everything goes as expected, the return should always happen here, and we should be able to see our expected result. Let's try it out. We definitely see an error here, and let's try to fix it. Okay, so I should make it as a tuple instead of try to join 2 things at a time. I should not pass 2 arguments, but instead just a tuple. So you can also do it here. And of course, this is an obvious mistake I made. Cool. Yeah, the answer got accepted. So that's the end of this video. Hope you enjoyed it. Thank you.